Okay, so we're looking at example 3 from chapter 7 of the stats. In this scenario, we've got a single observation taken from binomial distribution. There are 6 trials, probability of success P, and we've got a null hypothesis of P equals 0.35. So this is the probability we're going to assume is in place at the moment. An alternative hypothesis that a probability is greater than 0.35. Now, because it's just greater than, it means we've got a one-tailed test. Okay, on example 4, we're going to have a look at a two-tailed test, but just a one-tailed test, and we're looking at a 5% level of significance. So essentially, when we're going to try and find the critical region, we're going to try and find what is the first value for which, when we plug that in, the probability drops below 5%. Now, here's the thing. If this is a greater than test, so we're looking at the probability is greater than 0.35, that means that we are going to be testing probabilities that are greater than or equal to. Okay, if this is going to be a less than, we've got to go less than or equal to, and I'll show you a bit more on example number 4 of how that works. But essentially, we follow the inequality here. If they're looking for the test being greater than 0.35, we need to look at probabilities that are greater than or equal to a given number, and that's going to let us know what our critical region numbers are. So I'm going to use my calculator. You can bring up tables of values, but I'm going to use my calculator for this one, and because I'm going to need to try a few different ones to see which ones work. So I'm going to plug a few in. So I'm going to use the list function on binomial CD. Now remember, they give me the less than or equal to value, so we'll just play around with that in a minute. So let's have a look at x. So let's just try a few. So we go 2, 3, 4, 5, and 6. You could have started at 3, I guess, but you want to make sure you're not missing out on anything. So I've got 2, 3, 4, 5, and 6. I go through, we've got n is equal to 6, and a probability is what we assume it's going to be, so it's the null hypothesis probability, 0.35. And that gives me all of these values. So we've got probability that x is less than or equal to 2, 0.647. Probability x is less than or equal to 3, 0.8825. X is less than or equal to 4, 0.9776. And probability x is less than or equal to 5, 0.9981. Now remember, we want greater than or equal to values. So how do we get that? Well, we've got to subtract these from 1. But think carefully. When I subtract this from 1, what am I actually finding? If I subtract 2 or fewer from 1, the probability of 2 or fewer from 1, what am I getting left with? Well, I've taken out 2, 1, 0, so I'm getting left with 3 and above. So the probability is greater than or equal to 3 would be 1 minus this, 0.353. Probability x is greater than or equal to 4 would be 1 minus probability it's less than or equal to 3. So 0.1175. And then greater than or equal to 5, 0.0224. And then finally, greater than or equal to 6, 0.0019. Hopefully you've remembered the trick of how we can subtract decimal numbers from 1 quite quickly. Out of these, we're now looking, this is a greater than, so we want the greater than here. Out of these, which is the first one that falls below 5%? So out of these, still too high, still too high. This falls below 5%. So now, my critical region is going to be anything greater than or equal to 5. That's my critical region. Now for that critical region, what is the actual level of significance? The actual level of significance is that probability there. So 2.24% actual level of significance. Okay, So hopefully all of that makes sense. Example 4 is looking at a two-tailed test. So we're going to have to go either side, but we'll have a look at that in a minute. Really important thing from there, from this one, if it's greater than here, we want greater than probabilities for testing against the 5%, 10% or 1%. If it's a less than, we're going to do the same thing with less thans. And the other bit is, because our calculator or the table of values you'll find in the formula book are only going to give us less than or equal to values, when I subtract them from 1, remember you've got to increase that number. 1 take away the probability of x is less than or equal to 2 is the probability is greater than or equal to 3, because I've taken out 2, 1, 0. That leaves me 3, 4, 5, 6. Okay.